All right, let's go ahead and get started. Hey everybody, Cassie here. I am doing tonight as a simulcast. We are on both Twitch and Unlonely at the same time. It's going to be an interesting experiment to see if either of the streams break, or if both of the streams break, or if Streamlabs breaks. Who knows what's going to happen, but for folks who have been using Twitch, you're welcome to stay on there. I am going to try and synthesize any questions that come along the way from both. I got both chats loaded up on my screen, so we'll see how it goes. Hopefully it'll work out. Welcome to the dev call. For those who haven't attended any of these before, or if you're watching a recording on YouTube, just to kind of go over what we do here. The purpose of these dev calls is to basically be a point where we can show how to use Q, talk about current topics going on with the protocol, and answer as many questions as we possibly can in roughly a 2-hour session. So let's not waste any more time on that and get started. Like I said before, for those who haven't been here before, one thing that I want to expound on is the mission. For those who aren't aware of the mission of Quilibrium, our goal is to become the base fabric of the internet and secure every bit of traffic that runs through it. In service of that, we have been building a lot. For those who did see the last one or didn't see the last one, quick recap: we talked about the passkeys part of the JavaScript SDK. We briefly touched on Triple Ratchet, and then started spinning up the Go HTTP server and talked about integrating it with the RPCs and started to wire in the pieces to do so. That's one of the really important parts of actually building an application on Q, because the way that Q works is a bit different than other protocols, but we'll get into the deeper details as we go along. Today, because we are on the precipice of a very, very huge event for Q, the release of 2.0, I wanted to cover a few things first, because there's a lot of new people, there's a lot of questions, there's so much going on and so many different avenues to get information, and it's just, I'm having to find myself answering questions a lot that have already been answered, so I'm just going to lump them all into here and hopefully tackle it once and for all. Probably not, but at least try. So to start things off, we're going to cover a few basic topics, talking about the guiding philosophy behind Q, some important notes about Bootstrap peers as we go into 2.0, answering some questions for people who have been coming from, other crypto-oriented networks, what Q is and how we're different, how the rollout of 2.0 is going to go, because that's going to be a very involved path, and I think a lot of people really need to know the minutia of it, because it's not a simple upgrade. And then once 2.0 is out, how do you use it directly for folks, especially folks who have been in the crypto space for a long time? They talk about topics like, how do I use a wallet? How do I take custody of my tokens? How do I interact with the network? There's a lot of things that are very unconventional compared to how things have been traditionally done. And a lot of that has been an unfortunate consequence of cargo culting and people not wanting to step too far out of the norms. But, crypto is still so small. So the idea of not stepping outside of the norms has actually been a limiting factor. And then finally, on those topics, what comes after 2.0? It's been a huge road to get here, but that doesn't, the job's not done. We're not stopping here. So what comes after? And then after all that, we'll dive into the dev topic for today, which is defining the overall structures for data that this example application Howler is going to use, how that relates to the hypergraph, and then an important note about the concept of delivery, which is a very unique concept to Q that other networks just don't have. So talking about guiding philosophy, one of the things that a lot of people really don't understand if they're very new, it's something I've been talking about from the very beginning, is Quilibrium's a very mission-oriented project. And what that mission is fueled by is the notion that freedom of commerce, speech, privacy, compute, and peaceful assembly are all inexorable universal human rights. And that's a lot, but what that ultimately means is that in order for us to enshrine that right forever, we've got a lot of things that this protocol has to do. And we've held that perspective since the very beginning. And if you've been following me for a very long time, if you've been a long-time subscriber on Twitch, you'll even remember this. When in 2021, I was talking about the Howler project, which the logo is embedded for this old page, Code Wolfpack. And I was talking about the breaking point where I was migrating away from building Howler and focusing on Howler as the primary project that I was wanting to work with, and realized that the internet is just plain freaking broken. And how we had to move forward from that was to essentially take the huge goal of essentially reinventing the internet from scratch. And on that note, I've been expounding on those considerations for a long time. I've been talking about how cloud providers are alarmingly hostile. I've talked about how trust is something that isn't baked into protocols. Or trustlessness isn't baked into protocols. We have to do so much trust of all these different service providers, of all this hardware. And we've come so far in cryptography and verifiable computation, but we're not leveraging it to its fullest potential. And so in order to actually achieve those aims, Equilibrium came to be. It's interesting because, we've held that perspective since the beginning. It's been part of our messaging since day one of this project that the internet's broken and needs to be upgraded. And God, now there's so many projects, so many companies that, some have started before us, some have come after us, and they're starting to copy our messaging. They're starting to copy some of our advertising approaches that, I've just done purely myself. And it's so weird to see those ideas get replicated by, these huge companies with large capital flows from venture capitalists. And the hilarity of it all is that they're just missing that you can't just repeat an idea to hijack momentum. You have to actually be authentic, and being authentic about fueling that mission means that you have to actually have that mission encoded into your entire project from the very beginning. And so when being authentic about what fuels the mission, we also need to consider what doesn't fuel the mission. And this is a kind of controversial topic. We talk about inexorable human rights, this idea of freedom of commerce, speech, privacy, compute, and assembly. And this is important, but there's a thing that people need to understand. It's not just a mission, it's also a philosophical statement. There's so much political literature out there that talks about aspects of this, that they say, like, what are the impacts of free commerce? How much is too much free speech? Or where privacy should be limited. But we take a very strong position. We call these inexorable rights, things that can't be limited. But politics, declares these things topics for debate. And that debate is different all over the world. And that's something important that sometimes gets lost in the discussions, especially around political discussions. The distinction between philosophy and politics for us is that in philosophy, nuance can evoke discourse and potentially solutions or ideas, but in politics, nuance is kind of used as a cudgel. Like, it's just something people beat people over the head with. It's where goalposts get shifted and mission-driven projects get derailed. So we designed the protocol such that users have control over their own rights, that they're able to control the nuance needed for themselves in their jurisdiction. That's why, from the very onset, I was very privacy oriented with everything that was built, but also understand that there are circumstances where you need to actually handle things in a way that is compliant with the law. And a great example of that is, when you're engaging in commerce, especially in many countries, including the United States, there's a lot of different organizations that you can't necessarily send funds to and you can't receive funds from. And proving that compliance historically has been a matter of opening up your books, because that is the most expedient solution when everything is, just the raw data itself. But when you have cryptography, you can actually do that and still preserve privacy, which is why we have this notion of compliance bundles in the tokens themselves, where the tokens accumulate the addresses historically held that held those tokens, but consequentially, that bundle only lets you show whether or not a coin has been held by somebody, but not who all that was. It basically lets you say, I can prove that these known bad addresses never touched this money, but you don't get to find out who else had it. And that's a pretty powerful tool. So the last thing I have to say about that, and I see your question, Brian, the problem with politics is that it's infinitely regressive, and it's very distracting to mission-oriented teams to get lost in those types of political debates, which is why I tend to not get involved in them at all. And to answer your question of Biden or Trump, my answer is neither. People who know me personally know that I'm actually a very staunch libertarian and have been for a very long time. The next thing we want to dive into real quick before we get into one of the meatier topics. It's crazy how much working in crypto has made you a libertarian. Yeah, I can understand that. I mean, if you look at the very origins of crypto, all the people who were in the early cypherpunk space, we were all libertarians. It's not a surprise. Let's go ahead and turn the topic over to Bootstrap peers. Really important thing, as we're getting ready for 2.0, there's a number of people who have been running Bootstrap peers for quite a while now, and I cannot thank you enough for doing so. It's always been a volunteer effort. Historically, we've had some interesting challenges coming from the fact that, these Bootstrap peers are... Not only are they the first point of contact in the network, but the way that we originally had built the protocol was that Bootstrap peers also acted like any other peer on the network. And as we scaled out to, just the absurd size that we've become, it's just, it's impossible to actually do that anymore. That's just too much of a demand on a Bootstrap peer, because, when you got tens of thousands to hundreds of thousands at the peak of nodes trying to communicate with you like any other node, it's just overwhelming, and the nodes repeatedly would crash because of it. And so we made a very firm bright line with 2.0 that if you're going to move forward in 2.0 with a Bootstrap peer, you will be running in a special mode. It doesn't earn any tokens because it is strictly it's like a directory. It's a directory of all the other nodes in the network. It engages in peer exchange, which is really important. We use this as a scoring mechanism to ensure that Bootstrap peers are behaving honestly. It's a consequence of design of being, a limited number of Bootstrap peers on the network. We have to constrain how much traffic's flowing into them, and in order to do so, you just become a lookup service, and the rest of the network uses that lookup service to find other peers and then settle into their position in the overall mesh of the network. Huge thanks to everyone who's been participating. If that's no longer a working situation for you and you need your peers to continue earning tokens, then by all means, understood. Please just file a pull request to remove your peer from the Bootstrap peer list. I won't take any offense to it, and I don't think anyone else will. And also, second huge thanks to everybody who's been reaching out. I mistakenly posted in a bunch of different places telling people, hey, if you want to run a Bootstrap peer and understand that there's no tokens earned for doing so, then please reach out to me through whatever means you would prefer to communicate. And I didn't realize that, a lot of people are actually really excited to help. And so I've got a lot of messages to churn through, and a lot of folks have been asking basically the same thing, which is just, how do I do it? And so I'm going to walk through that real quick, so you know what to do, so I don't have to answer, hundreds of messages, which is currently what I'm sitting at for people wanting to run Bootstrap peers. I want to run over some requirements real quick and then show you how to do it. So first things first, if you want to run a Bootstrap peer, awesome. This node will be running in a special mode, does not earn tokens. I have to emphasize that because I don't want there to be any surprises. You need to have at least, if it's a really high-end machine and the processor is just incredible, then 4 cores is probably fine, but preferably 8 cores, preferably at least 16 gigs of RAM, and definitely like 1 gig symmetric. It's not a symmetric need as in it's going to be under constant demand. It's a symmetric need in the sense that like it might spike up to 1 gig, especially because we find that when new updates come out, a lot of people upgrade immediately and very, very quickly. And so by consequence, it tends to come in waves. And so just wanted to highlight this, that it's an important restriction. So if you've got all those needs met for whatever node you want to run as a Bootstrap node, awesome. Very easy to get started on that right now. All you got to do is just clone the repo under the release branch to either instantiate the node using the auto run script, or actually pick the releases off of our CDN, or build from source. Don't recommend that step because it's a huge pain, and it also means that you'll be running, straight from raw code, which, now you've got to have a build environment set up for Golang, Rust, and all the different dependencies that is involved in doing that. So either of those options, proceed as you prefer. And then once you've run the node, you'll get a peer ID, and that peer ID is important. You'll see it at the first printout of the logs. You can also get it using the peer ID flag when you run the node. It'll print it out for you. Then once you have all that information, then it's really simple. You just open a pull request. That pull request, we've got a few folks who have been adding and removing, so you can actually look at any of the more recent ones and you'll see a decent example. And all you have to do is just go into node config.go and add the multi-adder for your node. If that is confusing, if you don't know how to do that, like how to edit that code correctly and add in your multi-adder, if you don't know what a multi-adder is, I probably would recommend not running a Bootstrap node. You're free to if you're willing to learn all that, but I just want to cut to the chase and say that this is a really huge commitment, and by consequence, having a better understanding about how things works is kind of crucial. And so if something comes up and you need to respond and you don't know how to do that, it can cause some problems. So we recommend people who are more familiar with system management and a little bit of coding experience if you've got it. One of the questions in the forum also mentioned they were curious about the concerns about Bootstrap peers and whether or not they have any special advantages, and that is a concern for the traditional way that we were doing things, where Bootstrap peers were nodes on the network, because effectively they're in a position where they are acting as an actual node while simultaneously serving as a first point of contact for new peers. If a malicious Bootstrap peer under the previous gossip sub model were to actually start rejecting nodes, it might be really hard for that peer to get in and give them an unfair advantage. That is no longer an issue with the way that we are doing this. We basically have a separate scoring system for Bootstrap peers to ensure that Bootstrap peers are not behaving maliciously, that new peers can get in just fine, and there's pretty strong criteria in how we enforce that. So that concern is effectively eliminated. Bootstrap peers are really just a distributed hash table, and they were before too, but they're very accurately now a distributed hash table that is scored on whether or not it's behaving honestly, and will be eliminated if not. And we have a lot of noisy logging to help indicate if your node is misbehaving itself, or if you're, as a Bootstrap peer, if you see whether or not that node is misbehaving. So very important info. Be sure to make sure that everything is ports are forwarded, that you have your node configured correctly, that your machine is capable of running at the specs that need to be for a Bootstrap peer. But otherwise, that's basically it. Just submit a PR and then you'll get merged in. How do we see the sorry, I'm reading a question. I should clarify because I'm running two stream locations at the same time. How do we see the scoring for Bootstrap peers during 2.0? What can Bootstrap peer runners do to improve the score? It's very simple. Like it's not as convoluted as the Gossip sub scoring was. It's basically a matter of whether or not new node connections are being surfaced by that peer, if they're properly engaging in peer exchange. Peer exchange is basically a behavior that when one Bootstrap peer gets oversubscribed, that it's properly like cleaving off those peers and sending it to others so that the mesh can rebalance. And those are just really basic like distributed hash table and mesh management behaviors. So it's easy to catch whether something's misbehaving. So the score on it's simple. It's basically like 0 to 100. And if you're at 0 consistently enough, then you'll be essentially eliminated as a Bootstrap peer. Ivy just said, I missed that background so much. I missed it too. I had a family member staying over here for a while, in a time of need, and I didn't have my office available to me, so I have my office back, and my background's back too. Yeah. Thanks, Demi Poet. I had a feeling it was you, Demi Cinco, Demi Poet. It seemed like it. Also on brand with the bang. Okay, so next thing, comparing to other networks. This one's an interesting one. I have to be cautious here because there's some stuff I can't talk about yet. So it has come up that some people are very interested in interacting with the network in certain ways, and in doing so, they have certain expectations. And there's lots of people who have also asked this in the community chats, at least the community chat that I can see. I've been forwarded questions from other community chats. And so one of the things that comes up is like, does Q have a block explorer? How do I do certain things? Like if I go on the Etherscan, for example, I can see the lineage of tokens as they moved from one address to another. I can see the balance of an address, just general things that happen on public ledgers. How do I do that on Q? And the problem with that question is you can't. The design of Q is very privacy preserving, and so while theoretically, we use different nomenclature. They're called frames rather than blocks because it's meant to be more in line with like actual network behavior. So it's like a network frame rather than a block in a chain. We don't have the kind of visible information that blockchains typically have. Like, so Ethereum, you get a block, you can see all the transactions inside that block, you can see the contents of those transactions, you can see the addresses, you can see the overall affected state of all of the addresses, see the balances, all that stuff. You can't do that on Q. For Q, in order to actually see a balance, you have to have the relevant keys for the relevant accounts, and if you don't have that, you can't see it. The data is encrypted at rest. And so it's a very jarring concept for people who have come from other chains because they just expect that this data is out in the open. And historically, when this community's been so small and things have been completely out in the open and people haven't cared as much about privacy, which has been a weird narrative shift to be clear, but that's been fine. But when you're getting into this world where everybody's being brought onto a decentralized network, the notion of privacy is actually super important. Take, for example, your daily transactions with, fiat currencies, whether it's US dollars, euros, whatever. You don't necessarily broadcast to everyone, unless you're me, that you buy 20 bangs a week. That's just not something that people care to share. They don't care to share how much things they're buying and how much money they're spending or how much money they have. And it's super bizarre that crypto has moved into that mindset where that's just okay to be public information. And in fact, if you look at the original discussions around cryptocurrencies, the typical hygiene, so to speak, that was described for Bitcoin was oriented around this notion of never reusing an address, always using new addresses for every transaction, moving coins to new places, splitting, joining. Then there was also the concept of coin joining and mixers and all these things, and all of this was built around this notion of enhancing privacy. And so it's really strange that things did evolve into this open state, but Quilibrium's mission is to make the internet more secure and to bring privacy back to people. So no, this doesn't really apply in this context. There won't be a block explorer. There won't be a centralized repository of public information, because there is not public information. The chain, if you were to call it one, is private. So it's just a really important distinction, and it really needs to be it really needs to gel. Hey JP, it really needs to gel people with people a little bit better. All right, so the next thing I wanted to tackle, and this is honestly the big one, the rollout of 2.0. So for people who have been running nodes for a while, there's been this process where we, oh, hey, Phil. There's been this process where, we get an update ready, we go through this signing process to get everybody confirming that the build is correct and everything's ready to go, and then the published build with signatures is released, and then we move on from there, people upgrade, and it just rolls out pretty quickly. One thing I think that might not have been appreciated as much by people, because they've been accustomed to that easy upgrade flow, is we need to take a step back and realize 2.0 is a very, very different beast with a lot of implications that follow, because when we've been doing these upgrades, the consequence to token balances has been almost effectively out of band, and this update's going to bring a lot online and also have interactions that are important to consider. So there's a lot of moving pieces, and these things have to happen in concert in order to succeed. So it's not as simple of an upgrade as what happened with our previous rollout. So we're talking about July 20th as the ETA for this, and that is still our ETA, but it's not going to be an instantaneous rollout like the previous ones were. So let's talk about how that actually proceeds, so that people understand a little bit better, because part of that is, we've got the bootstrap readiness concern, which is why I already sent out that message and have been adding and removing people as that conversations come up, and we'll have a bright line to cut that off. And if people want to become a bootstrap peer later, great, but we'll have to cut that off pretty soon. So we have to have the bootstrap peers ready. The next thing is actually something that sounds almost tangential. In order to handle all the people who had bridged over to the ERC20, we have to temporarily suspend the bridge, because now the bridge needs to be upgraded to work into this bidirectional context, instead of this operating off of a collection of proofs context like it has been. And so we have to shut down the bridge for a period of time while we carry out this upgrade. So important note to draw from that, and a thing that people should know, is that in order to shut down that bridge, we have to schedule that shutdown of the bridge, which means that people should be prepared. So if you want to bridge to the ERC20 for Wrapped Quill, do that before Friday afternoon, because afterwards the bridge will be temporarily shut down, and the only way you'll have Wrapped Quill is if you already had it on Ethereum. So please, 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 if you planned on doing any bridging before the 2.0 upgrade, do this before Friday afternoon. And I'll actually have a fully detailed list of steps, times, everything after this stream, but I just have to emphasize, please do this before Friday afternoon. And then, of course, after that's done, then we'll actually move on to the upgrade itself. With the bridge stopped, we have to reach sufficient block confirmations to pass, so that we have everything in the encoded state that we intended it to be for all assets that were bridged over. To be clear, people can still move their quill around. I mean, it's a permissionless chain. You can do whatever you want. But what's important is knowing which of those assets are bridged versus not bridged. So that's why the bridge has to be stopped. That's why we need sufficient block confirmations to pass before we consider this locked in. And then once we've done that, we have to roll in all of that prior bridged state into a preload bundle for the 2.0 upgrade. That preload bundle will accompany the 2.0 update itself. It'll be encoded into the update, so that way all of this can happen as the upgrade comes out, so it can fit basically all in one for the update to roll out. So rolling 2.0 out, that's basically the easy part. We've already got a release management process, so we'll have the 2.0 update ready. People will be able to grab it, and then once that's rolled out and the nodes are coming online, we immediately move into the next part of the process. Again, this is getting into things that are maybe not as familiar for folks who haven't been involved in Q for some time. The core Quill token application is an application. It's something that is a learned consequence from other networks like Ethereum. Like one of the things that, if you talk to any old school Ethereum developers, what they said that they wish they had not done was they wish that they had not embedded the ETH token into the network itself, but rather had made it an application. We learned from that lesson. The Quill token is an application, but that means once the network is deployed, we have to deploy the application. So once 2.0 is out, then we'll deploy the token application, and that has its own staging process as well. So we'll have a immediate deployment of the token application with 2.0, then enable the hybrid mint process for people who have 1.4.19, 1.4.20, 1.4.21 releases. Those proofs that you've been accumulating for earning Quill, you'll be able to then mint those earned tokens immediately after the hybrid mint has been unlocked. And additionally, also like the live network proofs as part of 2.0 running. So that'll be the first token that effectively unlocks on the network. And then regarding that, the 19, 20, 21 proofs, there is a limited time frame. I'll publish more details about this after the call, but there is a limited time frame in order to claim those. And the reason is that obviously otherwise, how do you prove that those particular series of proofs were generated, in the past versus later on? You have to cut it off somewhere, or else it's basically an infinite money glitch. So that's the next step. Afterwards, we have to put the bridge application onto the network as well. It'll be essentially deployed in a suspended state. And then once that's done, we load the pre-post 1.4.18 and all non-bridged Quill data onto the token application. Then take the bridged Quill state and set it, or take the bridged Quill information and add that state to the bridge so that it is aware of what tokens it possesses. And then finally, the ETH side of the bridge can turn on, the Quill side of the bridge can turn on, and we are essentially live. And 2.0 is fully released and running. That's a lot of stuff. That's a lot of moving pieces, and there's even more nuance that I'm alighting over here because it's just so much stuff that is required to make this 2.0 release work. So before this upgrade actually begins on roughly Friday evening through Saturday morning, depending on how long it takes, hopefully it won't take long, we'll have to do a dry run of this on a testnet. So we're going to have to step through each and every step and verify that these things behave the way they're expected to on roughly approximate mirror of what the 2.0 mainnet will look like on the data that we currently have pulled in from ETH and all of that. So we have to run through each step, and if anything goes wrong, that means that we would have to suspend this upgrade process. Communication would follow, and then if there's any schedule impacts that come from this, which I guess there would be some schedule impacts, but if there are schedule impacts, then those would follow that. Otherwise, if everything worked the way it's expected, we immediately proceed to rollout, and once everything is confirmed, binaries will be released for signing, and we are live. So that's a lot. I hope that helps relay to people, like, we're excited. July 20th is when we're planning on getting 2.0 out, but there's a lot of steps we got to get through. It may not be until July 21st, for example, given how much work needs to be done, that the network is fully live. I just have to communicate that because otherwise it could turn into a bunch of confusion, and I want people to understand, how much has to happen in order for this upgrade to succeed. So, once we're in the world of 2.0, how do you use it? And so I've been doing a lot of work publishing guides, publishing, for example, let me hop over here. Cool, got it, yay. So publishing the RPC guide, so you can, if you want to use like raw programmatic calls instead of using the Q console, or sorry, the Q client, for example, this is the collection of RPCs that you can directly interface with your node. There are some important details. If you are using these RPCs, this isn't like using a public RPC. Keep this within a secure trust boundary, because if you are using the RPC, you are providing key material to that RPC. Now, that key material might not be disastrous. It's essentially a loss of privacy, not a loss of data, not a loss of access to your data in the sense that, like, people can't steal your funds, but it is a loss of privacy if you are not using an RPC that you don't control, don't have a secure connection to, and don't trust. Like, use your own RPC, run your own node if you want to be sure that everything is secure and private. But yeah, we have a bunch of details around how to actually use the RPCs, what these RPC calls do. It's essentially a list of all the various operations that are most crucial for people who are wanting to do basic account management, like what is my accounts balance, how many individual coin bundles do I have, what are my pending transactions that I need to approve or reject, and then basic permissions management, and I'll get into that in a sec. And then similarly, when you get to the coin-related RPC, let me see, where did I went too far. Classic. Oh, I had a typo, it's coin service. So anyway, the coin service RPC has a bunch of important commands as well. And this kind of gets back into what I was talking about with folks who hadn't or had come from other crypto-oriented projects and wanted to understand how to do things that were either easy because the data was public, or just something they were more familiar with. So the idea is that, for example, I want to send a coin to somebody. Okay, you transfer it. Okay, you just submit a transfer, and that creates a pending transaction that they have to approve or reject. And another important distinction, because if you've used ETH or other chains for any period of time, I'm not going to name any names because I don't want to drag people or their work, but like, if you've used a certain chain for a certain period of time especially, you will have been completely littered in garbage coins. And it's really annoying. It's sometimes complicated too, because now the tax man has certain objections to you being just freely given tokens, because those tokens apparently have value even if it's just garbage. So like that's a really unfortunate consequence of the truly permissionless design of being able to just send shit to anybody at any time. And so transactions on Q are two-stage. So you create the transfer, it creates a pending transaction. The other side has to approve or reject that transaction. Similarly, to other networks, if you do want to do that implicitly, you can do what's called a mutual receive and mutual transfer, where essentially the recipient is outright saying, like, I am expecting this transfer to happen. Here is the way you can send that. And it's basically like almost kind of like giving wire instructions to somebody who needs to send funds somewhere. It's kind of the same concept in practice, even if not how it actually works. But yeah, so those are the two options to send funds along for the Quell token. And then, like I said, with the account service, the coin service also has the ability to allow and revoke permissions for a given coin. With Quill being just an app, does this serve as something similar to an ERC20 token API? Yes, sort of. That's actually a really good question. So something to think about with ERC20s is that ERC20s are a contract, and I don't just mean like a smart contract, of course, but they're a contract in the sense that, or if you're a programmer, they're an interface. They have a list of specific methods that a given ERC20 implementation has to surface in order to be compatible with the standard or compatible with that contract, to fulfill that contract. The difference is that ERC20s don't have to actually obey the contract. You end up with these garbage tokens that trick people into investing in them, and then you find out that you can't transfer it, you can't sell it, you can't you're just stuck with it, and you just wasted money on a shitcoin. That's a very different distinction. So an ERC20 token API, if that token actually fulfilled the promises that contract is supposed to provide, then yeah, it would be something similar. But the difference is that in this case, those contracts can't be violated. Those expectations have to be met. And so you can think of that kind of similarly. What's a little bit different and a distinct nuance that you should be aware of is that with ERC20s and also ETH itself, the way that balances work for those coins is essentially a mapping of addresses to a given quantity. That works both at the protocol level with ETH, it works at the smart contract level with ERC20s. And Equilibrium doesn't work like that. Equilibrium is actually a lot more for people who are more Bitcoin pilled. It's more similar to the unspent transaction outputs, the UTXO model of Bitcoin, in the sense that those outputs are distinct entities themselves. So if you have been given, like, say for example, I'm Alice and Bob, Carol, Dave, whatever, I just get sent a bunch of different Quill tokens from different people. Those will all be distinct coin entities that I'm holding. My account will have a balance that reflects the total of those coins that I've accepted, but it does not actually lump them all together. In order to actually lump all those coins together, you have to merge them or split them if you want to split them into separate entities. And the reason why that's important is because it's another design decision that had to exist in order to solve a problem that exists in crypto, especially in account-based models like Ethereum. So when you receive a token from somebody on Ethereum, the entire history of that particular token that was sent to you is contaminating. And what that essentially means is that a great example of this is the griefing that happens from Tornado Cash. So Tornado Cash, for those who aren't aware, was a coin, and it still is, a coin mixing service essentially that let you have privacy on Ethereum by essentially serving as a entry point where a bunch of funds can go in, and it produces a proof that essentially says you have some quantity of coin that you can redeem, and it detaches the sender to the recipient. Now, there was a way to prove that the recipient and the sender were one and the same, and you could trace the funds that way. Not everyone necessarily used it. It wasn't required, and that was one of the damning aspects of Tornado Cash in the ongoing lawsuits and prosecution around it. Equilibrium is, of course, a privacy-preserving network, which means that the tokens across the board are private. So in order to facilitate compliance-related concerns, there is a need to have a traceable, not necessarily history, but a traceable confirmation that tokens aren't, for example, contaminated. The reason I bring this up is because a token contains a compliance bundle that is essentially like it's like a collection of all the addresses that previously touched that coin, and it's smashed into an opaque number, kind of like a black box that you can test. You can say like, hey, this address that I know to be Alice's, did Alice ever touch this coin? And it will give you a yes or no. It won't tell you who all touched it. You would have to query all of the address space, which there's just simply not enough time in the world for. Or you have to have really specific addresses in mind. And even then, the only way you can query that bundle is if you actually have the rights to read the coin, which means you have to have the key. So it's a dual layer problem being solved here. One, keeping the user's information private while simultaneously solving the compliance burden that has to be met in order to actually have legality in some locations, to put it simply. So you can do set, I'm reading a question. So you can do set inclusion like a Bloom filter of sorts. Actually, if you go to the, oh boy, this is going to be a big old pain. Here it is. Okay. If you go to the example token application, this is basically, if you want to deploy a coin on Equilibrium after 2.0, this is an example model of an implementation that would work. It's obviously like far more restricted than the true Quill token. So, obviously, if you want to add extra things like what the Quill token does with supporting many different key types and everything, you would have to, significantly extend this. But this is just a really simple example so people can understand the implementation details on how to make it work. But anyway, the reason why I brought it up was that when you, oh God, Safari is going to be a pain. When you actually look at this example, it is in fact using a Bloom filter. We have a simple Bloom filter applicability library that basically lets you apply a Bloom filter or test, and it's basically just taking those account references whenever you transfer a coin and applies the Bloom filter to it. And then similarly, there is a function on the pending transaction item in this case that will then perform set intersection using the provided lineage intersection versus the actual coin's lineage. And if there's any matchup for enough, enough bits, like whatever the Bloom filter is configured to be. So if it's like a hash function quantity equals 3, then it would return true, for example. You actually can think of this exactly like a Bloom filter for set inclusion. Playing a dangerous game. I've drank a lot of Bang Energy today, and it is 9:17 my time. All right, so getting back into the coin application real quick. Oh, I went too far. Man, I need to fix that. That keeps throwing me off. So the last thing I wanted to mention is that with the merge and split methods, you are inheriting all of that intersection data. So in other words, you can think of it like a Bloom filter. When you combine two Bloom filters, all you do is just OR them together. The same thing kind of happens with the private set intersection bundle of the Quill token. You are merging those two private set intersection bundles together and also merging the amounts together. So this is really important because most people won't want to do that if they need to manage their funds in particular ways. And so it's just a consequence you really have to keep in mind if you are merging tokens. Otherwise, just transfer the coins. Transfer the coins individually. There's no need to merge. It's just a thing that makes housekeeping easier for you if you want. A lot of this, these RPCs are the raw RPCs, whereas the intended model to use Quill, if you're not doing it programmatically, is through user interfaces that are much simpler and do all of this work of figuring out which coins to send and all the details of producing the transfer for you. So just something to keep in mind. And then finally, for the pending transactions themselves, did I not add that? Yeah, I did. Okay, it's right there. Simple, very similar to the token application, except I put intersect on the coin instead of the pending transaction. It is just simply approve or reject. And if you approve it, it goes to your address. If you reject it, it goes to the refund address. And important note, if you don't provide a refund address when you are sending a transaction, you are putting your address in the refund address section. Privacy note, that's important. If you are intending to send a coin to somebody and you don't want them to know who you are, you don't want them to know your address, then you want to manually define a refund address that is not your current address, or otherwise they will be able to see that. So just, nuance, things that are important. Okay, so the last thing I want to cover on this is management scenarios. Obviously, some people have been doing an insane amount of work running nodes, accumulating Quill. I am just constantly amazed at the intensity of how many people have jumped to this occasion and built up entire miniature data centers to start mining Quill, basically. That's just insane to me. But by consequence, you probably will want to have a more involved management scenario. Also, exchanges or various institutions will also want to have deeper involved management scenarios like cold custody. Okay. What happens if you refund to the receiving user? Yeah, that's fun. No, you can't do that. That is one thing that it actually checks before it will let you successfully execute the transfer. You have to specify a refund account. And not only that, to be clear, if somebody is trying to grief you, say maybe they know 2 of your addresses, and so they basically set the destination to one address, set the refund to another. So, refusing that transaction basically forces you to take custody. It doesn't. It creates another pending transaction. So that pending transaction still has to be accepted by that recipient. And so you can just leave a pending transaction sitting out there for forever. I've considered the idea of just doing an outright burn, if you get a pending transaction and you just want to screw them over and just hit burn. But I feel like from a housekeeping perspective, that creates an opportunity for a lot of coins to get lost. And I would much rather people leverage the fact that pending transactions can have expirations. So instead, use expirations. If you try and grief people, you're going to have a bad time. Oh yeah, okay. So cold custody. I tried to set an actual agenda in front of myself so that I didn't get so sidetracked and bunny trailing like last time. And so far, so good. So handling cold custody is a little bit more involved compared to some networks, less so than maybe some others. So, for example, on Ethereum, to have an account, you literally create a key. That's it. So if you have a key, you generate a public key from it, you derive the address, and now you have your address. And if the key is never, the private key is never exposed outside of an air-gapped environment, you essentially have created cold custody. That's about as simple as it gets. The problem with that in the Quill perspective is that if you are, handling the cold custody of a key, then how do you know when funds have been moved to that address? How do you know when somebody sent you coins? Because, again, everything on the network is private. So you would either have to do one of the following. You'd either have to have people sending you those pending transactions. They'd have to send you the data keys that expose those pending transactions so you can confirm that you have received those pending transactions. Or you can actually just do a little bit of extra housekeeping in order to make the cold custody account work. So generally, in cold custody environments, there is a certain audit trail process that has to happen in order for you to sufficiently meet whatever regulatory burdens, if you're subject to them, that you're properly managing these keys and that you do have them. Generally, the way that is done is through signatures, just simple signatures. In the Q case, we do actually have an expectation that if you are doing cold custody, it is far easier for your initial signature that proves that you have custody of that private key to just simply be an allow account request. And all that you do with that allow account request is Like, you don't give it any permissions to control the account. You don't give it any permissions to, you can't delegate, you can't approve transactions. The only thing you're doing is just giving them read rights by specifying a warm wallet, a warm account, to have read rights as a permitted account to list pending transactions. And by doing so, they now have the ability to see any of the data that comes through for that account. So it's basically a read-only delegation. And if you do that as your first signature, you have achieved two aims. One, you have proven that you have the private key for your cold custody purpose. And two, you have now originated the account on the network so that it is a distinct entity and can have data flows going such that you can actually see when that cold key is accumulating funds. And from there, you just take your managing account that is just read-only, and you're continuing to just read the pending transactions. In the warm and hot custody scenario, much simpler. You can just literally have just literally generate a key, use the derived Poseidon hashed public key value as the address. We have this essentially this model of implicit accounts. If you scroll up a bit, there's an account ref. Generally, refs that happen on the hypergraph are references by addresses. There is one distinct exception, which is account refs. They can either be an originated account, like I was just describing in the cold custody case, where you just provide the address, or they are an implicit account, which is a special type of account. That implicit type is either a default key derived account, where it's just an account that does not yet exist on the network, or it is a specialized type of implicit account. In the case of, for now, it's just type 0 is default key derived, Poseidon hashed, or type 1 is WebAuthn derived account. So in other words, address is still Poseidon hashed to the public key, but the signatures that are produced are obviously handled differently because WebAuthn has its own internal nonce management and unique signature structure that uses I can never remember that term. The way that it's encoded for the actual signature is slightly off the beaten track compared to what most people expect of just like stuffing raw data into the sign method and then it does whatever hash it needs to. So those are essentially the distinctions, is for right now just type 0, type 1. If we ever need to add support for other types, like say for example, if we wanted to support signed Ethereum messages or signed Bitcoin messages, it would just be introduced as another signature type, or sorry, implicit type. Okay. And then the final aspect is MPC custody. So for people doing MPC-based custody, if you have your own internal signing infrastructure, you use it the same way you always have. We don't do anything funky with the type 0 signatures or the regular signatures under a originated account. You're free to do just standard ED448 signatures for the ED448 keys, ED25519 keys if you're using those. I don't recommend it. Or BLS 48581. I do not know of anybody who is doing MPC ED448 or BLS 48581 outside of Q itself. So if that is the case, cool, let me know. But otherwise, if you do want to use MPC in your custodial model on the network, well, cool. You can actually use MPC-based signing processes over the network. And we'll dive into that, an example of how to actually do MPC signing over the network in a later dev call, but that is an option if you're interested. And if you are interested and want to do MPC-based key management, like say, for example, if you are a wallet provider out there that is doing MPC Lite, where it's actually just split key shares that you recombine in an enclave. If you're doing that and you want to actually be legitimately MPC oriented and you want to use a decentralized network to conduct your signatures, hit me up and I'll help you out. But yeah, that's the basic custody models that exist for key management on Equilibrium. There's some deeper nuance to it, so please read the full article and understand what you're getting yourself into when you're taking custody of keys on Q, because it is a bit more involved than other networks, especially if you're doing it manually via the RPCs. Make sure that I'm not missing anything. I feel like I'm juggling a lot of different chat windows right now. Okay, cool. All right. Okay, so the last thing that I wanted to cover in terms of questions that people were bringing up before we get into the dev topic itself, the roadmap after 2.0. So in the immediate term, the first thing that we're going to get deployed for after 2.0 is Q Console, which is the essentially our AWS console equivalent for the network. It's going to be basically an integrated development environment for building on the network. So if you're finding like navigating these raw articles of like, here's how you use the RPCs and juggling all of that, or if you found the example of the token application, trying to churn through all of that and the RDF data itself, which we're actually going to be covering later, the generated QCL, how to code against QCL, if all of that was just a lot and too much to handle, understandable. And the point of the Q Console is to make doing these things more graphically oriented, because at the end of the day, the way that the Q network operates is essentially a decentralized network for shuttling data in ways that preserves privacy and can it can run code over some of that data to either mutate or just derive from it or whatever. That's actually a really easy opportunity for a much nicer user experience in terms of a UI-driven development paradigm to build on Q instead of doing the raw code. So if this is too difficult and you want to actually build things in a much easier, user-friendly way, Q Console is the next thing that we're going to be rolling out, and that's the most immediate roadmap item. Outside of that, better browser-oriented flows. I don't think I'll actually get into the browser flow before 2.0 comes out, so I'm sorry I'm not going to be able to demo that and get everything else that needs to be shown during this stream, but essentially for the key management related processes, if you're just using passkeys, I'm talking about this model here, like what's actually involved behind the scenes in creating that passkey. How do I use a passkey without actually being intrinsically bound to a domain and all that stuff. A better user experience for that is something that we'll want to target after 2.0, but you've already seen an example of that user experience through our passkey dropdown. Outside of those two immediate things, one of the longer term goals is, of course, to essentially replace overall services on the internet. And in order to do that, that means that we actually have to be easy to navigate in the same way that people currently do with things on the internet. And so to build a bridge essentially to classical internet style services, we'll have a Q proxy that's basically kind of like if you're familiar with IPFS gateways, it'll be something kind of like that. It's like a Q-lite bridge into things that live on Quilibrium, as long as you have the relevant key information, which is why it's going to be pretty limited. Like if you're wanting to do any deep application interactions is something that you're not going to be able to achieve with the Q proxy. But if you're just wanting to do something simple, like I want to host a website on Q that's just a single page application, that you can do. Outside of that, codifying web schema resources for the network as well, so that it becomes very easy to just start moving more and more things from the classical web onto Q and just interact with it as native hypergraph objects. After those three items, Q Console, better browser-oriented flows, Q Proxy, the next thing is an improved white paper, because this white paper is a clusterfuck for anybody who is trying to read it. I'm aware of that. LaTeX is not my strong suit, never was. I was better at it in college, and even then I wasn't great. So at the end of the day, sorry, I will make the white paper better and more legible and more accessible. That is something that is on my radar. It's just a matter of priority. After that, then we're going to dive into things that really start to ramp up the advantages of what Q offers. So we're going to add broader bridge support, which means that, we're already importing ETH data. Like, the whole purpose of the bridge is to basically monitor the Ethereum blockchain for events that come through related to mint and burn in order to bridge on and off. And so in order to do that, we already have to have this pipeline that's ingesting ETH data. So why not just extrapolate it and support certain, to answer to Royal's point earlier about ERC20 and how it might be similar to the Quill token model. We have to support some, can't support all, ERC20 style tokens, NFTs, ETH itself, and essentially make it very easy and trustless to bridge over onto Q. We're already processing the data, might as well make actually cool shit with it. So that's the crux of the broader bridge support. We may target other networks. I'm not adding any details about networks we might support outside of Ethereum. The reason why I'm willing to say ETH right now is because we're already doing it. We're just going to ramp it up to more things. JP just asked a question on Twitch. When do you project that the network will cease to depend on your personal efforts to bootstrap it? I.e., will it be set free and on a final state? Does something like that exist? So, one thing I discussed previously on the open discourse forums that we have, this idea that Q is a one dev project. Obviously, I've been building it for 7 years. There's a lot of stuff that has accumulated and been built out by me, and that's sometimes led to unhealthy development models where I haven't necessarily deployed everything all at the same time or built out in the open. Some of that is informed from previous circumstances where when I was building out in the open, people were stealing shit. There's some deeper details to that, but at the end of the day, Q is no longer a single dev project. The VDF implementation in Rust was built by an entirely different person than myself. I know that they want to stay semi-anonymous, so I'm not going to name their name right now, but I thank you regardless. You know who you are. And so there's work that has happened on the protocol that has not been just me. And over time, especially when I start to have better resources out there, like an improved white paper that people can pick up and understand without having to really sit down and chew through it for days, I feel like more and more people will start to become acclimated and feel comfortable building on top of Q and building Q itself. As far as final dates for that goes, I don't have a date in mind because genuinely that's something that has to evolve. So one of the things that I mentioned on the Quillibrium discourse that we have set up was that I want it to reach a kind of, Satoshi point where, with Bitcoin, after about a year and a half or so, Satoshi became pretty distant and eventually separated from the project altogether and felt that it was left in good hands. I don't want to ever leave this project. I have no intention of ever leaving this project, but I do want the project to be healthy enough with maintainers that I could, not that I would, but that I could, and there would be no detriment to the project. So everything in service of that is what I'm talking about exactly with the post 2.0 roadmap items that are most immediate. Making tools easier to build on, making things more accessible for documentation, getting more and more people building Q itself. Those are my priorities. I want this to be a project that more and more people feel comfortable building rather than something that does depend on me so intensely. So the answer, sometime in the future. When? I don't know yet. We need more people. Royal asked, so does bridging an ERC20 give it privacy on Q? The answer is yes, essentially. If you bridge an ERC20 over to Q, that ERC20's entry point onto Q is public, because there's no way the bridge would work otherwise. Yeah, exactly. I don't know what I don't know. But Yeah, so when you bridge something to Q with the future trustless bridge for all ETH assets it supports, the entry point when somebody's bridging to Q, the address that submitted that, because ETH is a public blockchain, like that part's clear, that part's obvious. Where it goes on to Q, what address takes possession of it, all of that information completely private. So you do essentially give privacy to every single ERC20 on Ethereum through Q. So it can be a privacy vector where coins can come in and come out one other end, and you can't link the sender to the recipient. That being said, if you do like send like 100, Shiba Inu over to Q, and then you bridge it back at 100 Shiba Inu back to the same address, pretty clear. Another address, it depends on how much has been bridged over and how much time has transpired and all that. So people who are wanting to use the bridge as an anonymization vector, it's theoretically possible. It's more complicated than this simple description implies. So just be aware, yes, you can get privacy on Q by bridging things over. What that entails and how you do that is a different story. Okay, so after the improved white paper and broader bridge support, the next major roadmap item comes from all these things that are being built out through the subsequent release of the Equinox upgrade and the Event Horizon releases. Alongside that, from the company perspective, we're also going to be rolling out the AWS API compatible, so the S3 targeting, the KMS targeting, the Elasticache targeting, SQS, and API gateway, Lambda, all the like super core fundamental things that people need to build common internet services easily. Those are going to be the things that Quill Inc. is going to be focusing on. So I know I just like labeled or listed off like six different things I can count, 6 different things that's going to be coming out after 2.0. But like at the same time, like these things have also been previously worked on and are co-evolving with 2.0's release. So by consequence, like there's a whole lot that is in flight now. There's a whole lot that's going to be in flight after 2.0. It's a huge freaking roadmap. Time to build an FC client on Q. Should I talk about that? Okay. So one thing that people might have caught in the previous stream is that 2 things. One, I accidentally revealed some of the UI of Q console because I didn't realize that the local dev copy was running. The other thing that you might have caught on to from the stream was when I had the passkey integration from the SDK. I pulled the SDK over from Q console, which revealed a little bit more than I intended. That passkey integration for Q console actually does have integration with Farcaster accounts. And so while that is not a official like Quillibrium native concept, being able to bridge over Farcaster account data is something that Quillibrium Inc. is working on, and so it is something that people would be able to take advantage of and start using. So if you wanted to build a Farcaster client on top of Q, or if you wanted to build an ingestion pipeline that took in Farcaster data onto Q, these are things you can do. So I only mention it because I didn't want that to seem like alpha that somebody might have picked up on but didn't necessarily want to tell other people. I don't want there to ever be like information silos where people feel like they're getting privileged information because they happen to know one detail that someone else doesn't. I'm not in favor of that. I value privacy. I value secrecy. I don't value people not sharing information that is for educational purposes. Like there's a bright line I have philosophically there. Okay, so yeah, a lot of questions coming in now. I've got like Twitch and Unlonely questions. Okay, so will there be an update on funding for Quillibrium Inc.? JStacks, I assume that's how I say it, asked that. Not right now. I can't say anything further about that, but not right now. This is always the best time when Quill is live. I don't think I understand what's being said there. Cool, thanks, Phil. All right, so juggling too much. I don't think I'll do another simulcast. I'm going to have to pick one side, Unlonely or Twitch. I can't do too many windows at the same time. Full disclosure, like my streaming setup is not my actual normal working setup. I've got a monitor in front of me and a laptop below, and I don't do multiple screens. I do one screen, and I'm almost always just exclusively on my laptop. I don't like multi-monitors. I just use it because it works well for streaming. I'm the kind of person that maximizes every window. Just so you understand how much of a boomer I am. Okay, cool. So those were the big questions that I wanted to tackle before we got into the actual dev-oriented topic for this call. I do want to give like a brief opportunity for folks to ask any questions around the 2.0 upgrade, anything that wasn't already covered, in case you had any questions, and then we can move forward into the subsequent part of the dev talk. Stuck on Windows, so I gave up running my node. Yeah. One thing that if somebody's willing to, spend the time to get the Windows build working better, because I don't main Windows anymore and haven't for a decent amount of time now. If somebody's willing to put the time in to get the build working on Windows now that things are in like the multi-language Golang Rust stuff, that'd be awesome. It would be greatly appreciated, and we'd be happy to incorporate that build process or that platform into our build process. Would be greatly appreciated. Until then, the only thing I could recommend is either doing. I am sure I could Dockerize. Yeah, we do use Docker for the Linux build. So that's actually one of the things I was going to say is you could just do Docker if you have a what is it on Windows? I think it's like you have to have Hyper-V, and then you have to switch Docker into the Linux virtualization mode. Then you could just use the Linux build itself, or if you have like WSL, you can if you just use that, you can run it through that. There's a couple of different options. It's just it's a huge pain. Windows is pain. Like I said, I gave up on Windows a long time ago. I have a small amount of nostalgia for it, just because it was one of the first OSs I ever did anything decently major on. But on the perf side, depends. With Hyper-V, like the virtualization cost is not very high, so there is there isn't much. I should say actually, there isn't much performance penalty if you are doing a simpler virtualization route. If you are doing something more complicated, like you're doing like WSL, I can't say for sure. I don't know. I know it does all sorts of weird stuff, like overall like RAM limit, etc. It's such a pain. You're getting nerd sniped. Cool. Sorry about nerd sniping you. But yeah. Will there be a GUI wallet? No, there will not be a wallet. I'm going to keep emphasizing that. The notion of wallets doesn't make sense on Q. Account and key management is so diversified that, so for example, when you have like these RPCs to manage accounts on Q, accounts are just a reflection of a centralized key, centralized to you key. So in other words, like, it would be way more complicated if every single coin had its own public key. So instead, you delegate the ownership of a coin to an account. And so from that account, you can have many keys that stem from it, but at the same time, you do have a managing key for the account, and you can move funds using that key. Where that comes into play with wallets and why it doesn't make sense in the Q model is that you may have many accounts. Accounts are domain bounded. So in other words, if you are using like passkeys in particular, you'd have your primary node account that holds your Quill tokens, but applications that are built on Quill do not use the same account. Like you will have, so think of it more like traditional web. When I go to Google, I log in with my Google account. When I go to Figma, I could log in with my Google account. It might be tied in, but it is a consent-driven OAuth flow, or I could just log in with my Figma account. If I go to the Quillibrium discourse group, I log in with my my own account on Discourse. These are all separate accounts. And what I think is a really broken design that has infected crypto super badly, and the reason why I am pushing so hard against this idea of a wallet, is that wallets are an abstraction that is no longer in need. We needed wallets when browsers didn't support private keys. We have WebAuthn, we have private keys. But worse, wallets never had domain-driven abstraction. So in other words, when you had a key, your key was everything, which is why you have this scenario where somebody can make a imitation site, like a scam site. And it's happened to us too. For Quillibrium.com, there's all sorts of misspellings that people have created, and those pages serve up wallet drainers. And those wallet drainers only rely on one simple thing, which is you to take your wallet that is connected to everything you own and hit sign. And because it's so simple to do that and so easy to do that, it creates this scenario where people easily lose their funds all the time. It's one of the most common topics that comes up in crypto. It's the reason why so many people who have danced with crypto and gotten burned and get jaded and never want to come back feel that way. Because if you instead just took that one simple step and abstracted keys such that they were tied to accounts that were tied to domains, that one indirection suddenly makes everything so much more secure. Instead, think of replacing wallets with using your browser's passkeys. You could do manual key management if you want, or if you're doing stuff through the RPCs or Q client, you could use raw keys that you're managing yourself. But this idea of using a single key for everything, insane. We do not encourage it. We do not support it. It is intentionally meant to be as high friction as possible in order to try to do that, just so that you cannot do that easily. Like, you have to intentionally shoot yourself in the foot in order to shoot yourself in the foot. How cross-domain stuff will work if the API lives here and the site is hosted there. So yeah, like I said, it's not that you can't interface these things. It's that there's a consent flow. We're not going to get into the consent flow demonstration today. That'll be something that unfortunately will have to happen after we get 2.0 out. But consent flow, if you've done OAuth before, and I'm sure almost every single person has, whether or not they know it, if you've done sign in with Google, if you've done sign in with Facebook, or you've done sign in with Twitter, I'm trying to think. There's so many different examples of this. Not sign in with a Farcaster because that's not actually OAuth, but basically that same kind of concept of, I have an account somewhere else. I want to grant permission to another place, another website, to access certain details about my account. If you go back to the RPC, if you go back to the RPC page, one of the things that I illustrated in the cold custody case is a read-only perspective or additional permitted operations. So if somebody were to try to do this, if somebody were to try to make a scam site, for example, that was going to steal all of your Quill tokens, they would have to produce a redirect flow. If you're using the browser-based custody model, a redirect flow to you accessing your private node RPC to generate that request, to prompt you. It will tell you, I am asking for this permission to basically steal everything in your account, which is a very different scenario compared to wallets, which give you very opaque information. So instead, like, you're being told explicitly what permissions are being asked for, to which any sane person would then be able to say, why would I be willing to give away everything I have? And so kind of like yeah, except it's much more explicit. Getting permissions on Q is very different from the ERC20 allow, or what is it called? Is it allow? I don't remember. The way that ERC20 permissions work, basically, like, you can give an allowance to another account, and it's for a certain amount. It works differently on Q. You are permitting operations, and so if you just wanted, like, for example, if somebody wanted to ask for access to, like, say your tax software, for example, wanted to say, hey, I need to see all of your coins. I don't care about having the rights to them. I just want to be able to see them so that I can import that data in for your annual tax filing. Then it can ask you specifically to list all of the coins, and that's it. It won't get any extra permissions, and it'll tell you exactly what it's asking for, which is a very different scenario compared to traditional crypto wallets. Okay. Wow. Okay, man, people keep asking questions. This is cool. I hope that I'm going to have enough time to actually get through the dev topic. There, okay. Okay, so what are some low-hanging fruit mainstream user applications that 2.0 unlocks that you are excited to see being built? By and large, the thing that I'm most excited about for 2.0 is 2.0 itself. Just because it's been a long road to get here. But seeing built on 2.0 specifically, like, the whole crux of this started because I was trying to build a clone of Discord. I might not be, like, necessarily a social media queen by any shot. Like, I don't have millions of followers, and I don't ever care to. I don't care about the popularity games of social media, but I really care a lot about people being able to have a space to freely speak their minds without having to fear being deplatformed and depersoned. It doesn't mean that I support people saying absolute garbage. Like, I don't appreciate people saying hate speech, for example, but I am a firm believer in the First Amendment. I am a firm believer that sunlight is the greatest disinfectant when it comes to discourse. And so no matter how much I may disagree with a person saying something, I will defend to my death their right to say it. And so anything that helps promote discourse or communication or social media platforms or anything in that kind of context, that is one of the things I'm most excited to see explode on Q, because right now there are thanks Royal. Right now there are so many crypto-oriented social things that are burgeoning, and obviously, like, I've been doing a lot of work for the Farcaster team, and historically and presently, and I strongly believe in Farcaster because it's a very unique take on doing social with an adjacency to crypto. But that's the important note, is that the reason why it is adjacent to crypto is that crypto itself doesn't have something outside of what I'm building with Q that can scale out to the needs of social. Like, right now, consider the iMessage case. iMessage, in their last figures, was like 2016, the last time they publicly stated anything about their overall message flow. In 2016, they had over 200,000 messages a second. 200,000 messages a second. There is not a single network that is actively out there as an L1 or L2 that can meet that scale. And that's what was one of the main, informing decisions about how Q was architected, was so that it could scale out in parallel to sufficiently meet that burden and more. And so that design, of course, it led to all of what's happened today. But the reason why I'm excited about social on Q is specifically because it's never happened before. It's never truly happened before in a way that could scale out to actually achieve a social network or a social media product on a crypto platform. That just has not existed yet. So that's what I'm most excited about. And in terms of low-hanging fruit, like, I consider it a low-hanging fruit because the distribution channel of Q is very, like, data forward and very explicit about like propagating data as it's being modified. So in other words, like that notion of delivery, and I was going to get into that, might not be able to by the end of this call given the time constraints, but the notion of delivery, which is just that when you impact data and that data has subscribers to it in the sense of like relevant keys, like say that you have created, for example, man, am I not going to be able to use keyboard shortcut? That's a pain. Okay. So say that, for example, here I have. I'm just gonna run through it. So say that I have an account. Say that I have a coin. Say that I have created an allowance, like several allowances. Like I have given 3 different accounts the right to view everything about my account. If I've done that, then at the same time, they are now subscribers. Like conceptually speaking, they are now related to me on the hypergraph. And so when there is something that affects the data of my account, delivery is the concept of anything that mutates that data about that account has to be communicated to all of the other subscribing parties. So it's like a way that information flows are distinctly managed. If you are familiar with like the message passing model of like the actor model, or if you're familiar with like communicating sequential processes as a like computer science concept, this will feel very much like the inverse of the actor model in the sense that like I'm no longer creating actors, I'm actually creating recipients. Like the messages that get sent to those recipients are a consequence of the state mutation of data on the network. Okay, another question. So do the keys rely on an active node, and as such, if the node is decommissioned, those keys and quill tokens are inaccessible? No. So I talked about a couple of different models, like the Q client, the command line client. That doesn't require running a node at all. It essentially does embed a mini node in itself to construct the actual network interaction, but it's like a light client, effectively. The RPC is if you are running a node and you do want to do these interactions more easily and just let your node basically shuttle it around for you instead of having to deal with like a separate node instance or a Q client or anything else. You just want to use your node, is an option. It's primarily intended for people with a lot of keys so that they don't have to, use the Q client with a bunch of different config flags. And then the browser model, which is something that we didn't get to get in as deep on. So no, you don't have to have your node alive in order to use your account data. It's just that in terms of like privacy-oriented concerns, you would want to leverage a node that you control, or at least a light node that you control through like the Q client, in order to interact with that data securely, because somebody in an MPC-oriented process, somebody's got to handle your data. You would much rather it be yourself in order to actually complete the overall garbled circuit processing. So you have to be one side of that participation, or else you are providing that data to somebody. You're exposing that data to somebody. Okay, cool. I think we tackled all the questions. I think we got to the end of that. Okay, cool. So now the main thing, which we now only have roughly 30 minutes for, we're going to talk about RDF. For those who do know what RDF is, congratulations, you have reached the end of the talk, and you can tune out now. If you don't know what RDF is, it is a important attribute of Q in the sense that I've joked before that Q is a combination of Web 3 and Web 3.0 in the sense that like Tim Berners-Lee is referred to Web 3.0 as the semantic web, and the semantic web is achieved via RDF, and of course Web 3 in the crypto sense. I had never thought consciously about the power of social media being implemented through... Oh. Yeah. I mean, it's like I said, it's from the very beginning of the story. We've been, social media was our bread and butter. But anyway, RDF is basically the means in which we define the schema of an application, of the data of that application, of the requests and responses of that application, and ultimately it gets encoded onto the hypergraph itself in a format that is efficiently queryable. This is important. This is important for two reasons. One, because schema enforcement on a network that retains your privacy, obviously you'd run into some serious issues if you could not verifiably store information without seeing that information. So schema enforcement is something baked into the core of the network. But additionally, schema enforcement is really valuable in this context because RDF is a queryable language, so to speak. Like there's this notion of what's called SPARQL, which is a query language meant for RDF-based data. And RDF, as a queryable data set, is most efficiently queryable using hypergraphs. So this is kind of why all of this pieces together and why RDF is a very naturally suited item to use for formatting data on Quill. So to illustrate how that comes into play, I'm going to talk through the token application real quick as it was defined. I'm also going to, for the love of God, just copy this out and put it somewhere else because Safari is being absolute trash right now. Let me do that in a way that doesn't burn me. Oh, that's so frustrating. One sec. Okay, I'll do it this way. Cool. Okay. So we have it pulled up in VS Code. So you can see an example here of the token described in RDF. And one thing I mentioned before is that we have an immediate pipeline that goes from RDF into the QCL types. This is because actively converting between two different formats that essentially relate to the same data, if you don't have a conversion pipeline for that, it's a massive pain in the ass. You're gonna make mistakes. So much easier to just do it by code. So structurally, RDF is very simple. It is a triple language. Basically, you have a collection of subject, predicate, object. That's the entire basis of this language. It is literally a triple. So this notion is you have an account, which is a RDF schema class. And then from there you have distinct attributes which flow from it, which inherit from the parent item itself. So in other words, I'm defining an account, which is already defined for you, but I'm just illustrating this. So I'm defining an account. It is a RDF-based class. I gave it a label so that comments will generate. And then of those items, or of the account, I have a couple of different properties. And so properties are defined in the same way that classes are defined, because again, RDF is just subject, predicate, object. Very simple. So I have a total balance. It is a property. That property has, attributes that you have to consider. So in properties, you have this notion of a domain and a range. And if you're familiar with map terms, then you know that that's a mapping that is happening here. But in this case, what domain is it's saying this particular property, what type is it? Just to put it in plain English. And so in this case, we have a collection of defined types that are unique to QCL. I mean, not really that unique, but they're important for QCL's sake. And so in this case, total balance is an unsigned integer, or a QCL uint. And it has a defined size, and it has a defined order in which it appears inside that particular type. So in this example version of an account, it has a total balance, it has a public key. They are both properties. They have specific QCL types with specifically bounded sizes, and then the order in which they appear. And then the range applicator basically says that it goes to the account. And that's really it for defining a single a single RDF-based entity in this approach. Let me switch this over real quick because this is serious pain shuttling through all these windows. Okay. All right, we're good. So yeah, let me actually. I don't remember if I made this like live map or not. I think I did at one point, but the browser was just like such a pain in the rear. We'll find out. Let's see. No. Okay, I did. I made it no longer editable. Damn. All right. I'll illustrate a different way. So let me see. Where's Howler? Where's the Howler API? Did I not have that open? Hang on a sec. Dang. Okay. All right. And to avoid exposure of any other adjacent projects, I'm going to move that window down. Okay, cool. Okay, so now I have the Howler API open. Let's get this. I'll have to get to that in a sec. Okay. So, if you remember in the last session on the Howler API, we already imported several pieces of the Quill node. I'm going to go ahead and import another just so that you can see a simple demonstration of defining RDF and then generating QCL code out of it. So the first thing would be, I think it's under schema. Man, am I really going to forget this? Yeah, it's right there, schema. Okay. Oh, crazy. Weird. Okay, it imported it just fine. I don't know why it's like this. Why is it being so frustrating? Okay, I'm going to save myself some time here because I'm... Yeah, okay, cool. Get back to there. Okay, cool. So we define a turtle RDF parser, and the reason is that it's the turtle syntax for RDF. We'll just call it parser. And then from there, there's a method to actually generate the QCL based on a document that was provided to it. Oh, this is so annoying. This is the one thing I actually don't like about Max, is that you can't, like when you command tab, it opens up all of the windows all at once of that one application. I just wanted one. Okay, cool. So I'll go ahead and illustrate this real quick. So structurally, we want to take this QCL and run it through the parser in order to actually generate, or take the RDF and run it through the parser to generate the QCL output. Then we can actually start building code against those types. So in order to do that, I'm just going to actually basically shuttle this through as a simple application. I'm so freaking lazy. One sec. Okay, I'm gonna have to... You know what, screw it. I'll make it a bit more interactive. Okay, instead of rambling to myself, I'm actually just going to walk through this real quick so that people can follow along. So I'm going to go ahead and temporarily create a post mechanism so that you can see what I'm trying to do instead of me just like furiously typing in a different screen. Okay. And then we'll want to take the raw JSON data coming through. And we'll just structure it pretty simply as like a request. Okay, and so now we'll have the request data coming through, and from there, all I have to do is pipe it in. Oh, helps it. What? There. Like I said before, I cannot talk and type. It is literally, unless I'm literally saying what I'm typing, it is one of my worst streaming traits. I wish I could not do that, but unfortunately, it is how I'm built, because I'm a boomer. Okay, so then I can take the parser and then generate QCL from it. And if there is an error from it, we're just going to actually go ahead and pipe it out all the same, because we're going to do a simple curl. So let's I guess either way, it doesn't really matter. I'm trying to think of it. Yeah, screw it. Okay, we'll just do it that way. You can literally see the effects of caffeine wearing off on me in real time, because I start to like turn into like Joe Biden in his debate performance in terms of my ability to actually say things. Okay, cool. So let's go back to the Howler API, and then we'll go ahead and go run. Okay. Cool. And so now we have the RDF to QCL. Go ahead and post, and then localhost. What port is it? 5173. And what's the endpoint? RDF to QCL. And then oh man, that's gonna be a big old pain. I'm gonna have to escape that. You know what? Screw it. Like I said, I am always going to be lazy about this. We're going to go ahead and confirm that this actually goes through the way it's intended to. RDF. Big old payload. And then closing. And there we go. Okay, weird. It is listening. All right, so I'll go ahead and try just a empty object and see what the hell's going on. Why is it being... oh, not found. Am I somehow... okay, that's fun. I love live debugging. Yes, it's because I'm live. If the demo wasn't being streamed, everything would just work. Yes, exactly. God, that's super annoying though. Why in the world is it... and there we go. There we go. Oh my god. What a fucking mess. Awesome. Okay. So that incredibly long walk for a short drink of water was just to generate the actual output data. Okay. What you end up with this particular thing. So RDF is just schema in the like classical context. In the Equilibrium context, you're using it to define structures and in specific relationships. And those structures and relationships get converted into QCL types and some basic QCL code when the tools aren't like completely betraying you at every single end of the earth, so that you can actually start writing applications that interact with those types. So one thing that you'll notice here, in terms of the actual changes that happen from RDF into QCL, you'll see a few different relationships happen, a few different relationships between the actual input data to the output data. Not only the type names, but you'll also see the size differences as well. So for example, QCL uint size 32 comes out to a QCL uint 256. And the reason is that you're saying this is a size, and sizes are consistently in bytes in RDF for this QCL size property. Whereas in QCL, the types are going to be either byte array bound or array bound in general, or they're going to be very sized down to the bit level. So all of your individual types are going to be essentially rounded to 8 bits. So that's why the size type doesn't expose it as bits, it just exposes it as bytes. And then order dictates, of course, the order in which those things appear. These things are, the ordering is important, the sizing is important, and one thing that I was hoping to get to tonight, but we are well over time because I was too busy fighting a fucking curl command. One of the things that I do want to mention here, though, that's important is that when you're defining an application over Q and you're trying to scope out the schema using RDF, you'll notice that the sizing is constant. So in other words, I define an account. It has 32 bytes, 57 bytes, and that plays out when you unmarshal it to 89 bytes or marshal it to 89 bytes. That fixed sizing is one of the defense in depth characteristics of Q. You cannot have variably sized structures. So in other words, you are maximally defining the size if it is something that is variable in content. So what I was going to get into, and I'll just simply touch on for tonight since we're going to have to wrap things up, what I was going to get to was the structure for message types on Howler. And this is part of the design intentions of Q, is that it's intended to make you make secure design decisions by default, making the insecure design decisions harder to do. So when we were going to structure out the message type, for example, that message type has content, that content has text, and that text has a fixed size. And the reason for that is that if you weren't to do a fixed size for your message type, then there is a very huge field of analysis that exists, like in the field of cryptanalysis, where you can start to infer some details of data about a given message, especially for text-based communications, that you can infer things like, what are they saying? Like, if there's 2 bytes coming over the wire, is it okay? Is it no? Well, it's probably one of those two, but it's certainly not yes. And so by eliminating that factor, you end up solving a pretty huge pain in the ass for security purposes. Like you keep the scope of the data type fixed to a given width, and you eliminate an entire class of vulnerabilities. Whew. Man, okay, that was very frustrating. Feels really unfortunate to have to end the night on that note. But we're definitely well beyond time now, and I need to log off for tonight. So in the next session, now that I have solved apparently the most bizarre copy-paste behaviors I've ever seen in my goddamn life, in the next session we're going to touch on the remainder of the RDF process, scoping out the data for Howler, then moving into how that RDF data is actually embedded onto the hypergraph and how you can query that, because we're no longer dealing with terminal shit, and then into the delivery path, and then finally executing code on the network so that Howler is a end-to-end complete application within basically 4 Twitch streams. So cool. Yeah, I know, right? We learned copy and paste today. Fuck. I have never seen that behavior in my goddamn life, and that was so frustrating. Okay, so I'm going to have to go ahead and wrap things up from here. Greatly appreciate everybody watching. I am going to carve out the 10 minutes of frustration I just dealt with there for the YouTube video, so that it's not just going to be a waste of people's time. But we will be back. I'm going to try and shoot for Sunday. It's going to be very contingent because obviously we're going to be dealing with a 2.0 release over the weekend. So if something comes up, we'll have to move it. It may end up being a regular Wednesday cadence. Who knows? But until then, sorry for the frustrations there. Thanks for staying tuned and asking questions along the way. And we will see you in the next session. And also when 2.0 lands.